So another thing you will notice is I have actually added another calculator. This was a GeoGebra calculator. So just another one if, that one seems to work better for you. So just as an extra tool, which right now we're not really quite anywhere where you really need to work on calculators, but I've just added that as a resource. So this is kind of what Terry was talking about, was what does this symbol mean? So this symbol over here is where they're talking about B is a subset of A. And then remember, we did talk about this symbol where we talk about it is an element of. So in this first example, of course, they're asking you if 8 is an element of set A, and obviously you can see in set A, there is no number 8. So obviously that guy wouldn't be an element. And then for B, they are saying is B a subset of A. So remember, for a subset, all the elements that are in B, all of those elements have to be in A for B to be considered a subset. So of course, 2 and 3 are part of set A, however, 8 is not. So that's why B cannot be a subset of A. So remember, subset is, as they had defined, should be that every element in the subset should be part of the main set. So that's what that symbol basically stands for, is for a subset. And then here you can see they're kind of getting into the intersection and union of 3 different sets. So again, remember, when we're talking about intersection, we are talking about all that is common between the 3 sets. So when you look at sets A, B, and C, only those elements which would be, listed in all 3 of them would go under the intersection. So in this case, what do you see as being common between A, B, and C?
1.
Yeah, just the number 1 is common. Now, if they did a combination of just sets A and B or B and C, then those numbers would change. But since they're talking about all 3 of them, the only element that is common in all 3 of them is going to be number 1. When you're talking about union, kind of like how Terry was mentioning before, union is where you take what's common, but then you also list all the other elements which are not common. The only thing you have to be mindful about is not repeating any of the numbers. So you will write the number 1, obviously only once. Then you can see A and C have 2 in common, but obviously we again listed only once. Then you have the number 3. So that would go next. And remember, we did talk about conventionally, we do put the number sets in order. So you would write these numbers in order as much as you can. So of course, the next one would be number 4, 5. There's a 6 after that. Let's see, there's no 7, but we can see an 8, 9, and 10. So, just basically listing all of them out. And that's what you are doing in these examples, is basically just listing what all of these, elements are going to be. Now, this is where Terry was talking about that null set. So you can see in the first part, they are asking you to do the union between A complement and the null set. So obviously, since this is a null set, which means an empty set, there are going to be no elements in there. But again, by definition of the union, we take everything that's in A complement, we would take everything that's in the null set and put them together. So obviously the null set is not bringing any elements. So all you are doing in this one is listing your A complement, elements. So as you can see, set A is defined as these 6 numbers. Here is your universal set. Now, basically, if you look at this, your A, B, and C are all subsets of the universal set, because all the elements that you have in A, B, and C are part of that universal set. So anytime you are doing your complement, basically look at set A and then whatever is in set A does not go into A complement, because remember we were talking about how this is sort of like the negation that we were talking about in the logic section. So everything else except 2, 3, 7, 9, 15, and 17, except all of those that are in set A, the remaining of those numbers are going to be in your A complement. So, that's going to be your 1, 4, 5, 6, 8, 10, 11, 12, 13, 14, let's see, 16, 18, 19, 20. All of these are going to be in A complement, and that's the same thing you're going to list over here. Because again, like I said, this is an empty set, so it's not bringing any elements to that union. So just everything from A complement. Does that make sense? Yeah. Okay. And then let's see, this one, as you can see, is going into intersection. Then they are also doing intersection between A complement, union B. So same thing, everything that you had listed in A complement, you are going to then take a union of that set with the set B, and that will become your answers over here. Now, can you tell me how we can break down that last part where you have B intersected with A, and that's in parentheses, and then the intersection with C complement?
Do the part in the parentheses first.
Very nice. Yeah, so you're still kind of using the idea of order of operations. So start with the parentheses part first, define that, and then you will do the complement, the intersection with C complement. So let's start out by doing B intersect A first. And I'm going to make this just a little bit smaller so we can have all of this on the same page over here. I need to get that universal set in. There we go. So let's start out with B intersected with A. What do you think this will end up giving us? And again, send your answers to me through chat, and you can do a direct message to me. So B intersected with A. All right, I see Terry's answer. All right, Amanda, Michael, Destiny. That's fine. No problem, guys. All righty, so as you can see, the only two elements that are common between A and B, or B and A, however you want to look at that, is going to be 15. Oh, why are you not writing? There we go. And 17. Now, before we can do the last part, which is using C complement, let's go ahead and define what C complement is going to be. So again, let me see what your C complement ends up looking like, guys. Alrighty, let's see, I've got Got Sarah, Destiny, Terry. Oh, okay, Sarah, I see that. Okay, so Destiny. I think Destiny, you might be missing a number in there. No, Amanda, the parentheses are just being used as a grouping symbol. So basically what they're saying is first you're going to do the intersection between B and A first, and then whatever that set comes out to be, then you will do an intersection between, which is 15 and 17 that we came up with. So between that and then whatever you have in C complement. So the parentheses are just being used as a grouping symbol to say, do the B intersect A first, and then we'll do the intersection with C complement. All right, I see answers from Kendall and Michael in there. Okay, so let's take a look over here, guys. So in C, you have 2 and 3, so that gets canceled out from the C complement. Okay, Destiny, all righty. Then 14, 15 are in C, so they cannot be in C complement. And same thing with 17 and 18. So that leaves us with, and then most of you, of course, already had this, the one, sorry, not here. The one for, let's see, all the way through 13. So 5, 6, 7, 8, 9, 10, 11, 13, let's see, 14, 15 are out, 16, 17, 18 are out, 19 and 20. All right, so now we have the B intersect A, we have the C complement, and then of course you are doing an intersection between these two sets now. So what do you think is going to be in the intersection between B and A and C complement?
Nothing.
Nothing, because 15 and 17 were part of C, which means they are not part of the C complement, right? And that's the only two numbers we have in B and A. So obviously then this comes out to be an empty set. And as you can see, for an empty set, they are asking you to put in does not exist or DNE. Anybody have questions on this? All righty. So as you can see again, guys, as far as the complement goes, you are looking at anything that is not going to be in the original set. So since you were doing C complement, the C complement will have everything which is part of the universal set, just not part of C, right? Same thing with that A complement in the first part. So Sabrina, with the empty set symbol that you see over there, basically there is nothing common, but remember the union is if you have something common, you put that together. If you don't have anything in common, you still bring it all together. So A complement, that first set has so many elements in it. So you take what those elements are, which will go under the union set. And since the empty set is not bringing any element of its own, you're basically not going to have anything new coming from that empty set. So all the elements you will have is going to be just from the A complement. Now, however, if we change this symbol from union to an intersection, so if we change this and did A complement intersected with the empty set, then this would be basically an empty set. because, obviously there's going to be nothing common, like you said, between the empty set and A complement. So then this one would then come out to be, does not exist for this guy over here. But because this is a union, and a union basically means take everything you have in set 1, combine it with everything you have in set 2, and put it all together. So even though this guy is not bringing anything to the party, you basically have all the elements from A complement, which will go in here. Okay, we can take a look at what your problem is showing and see how we can specifically address that question. So not a problem. Just if you can hang around a couple minutes after class, I'll take a look at it. So any questions on union, intersection, and complement at this point, guys? Okay, let's get a little bit more detailed into Venn diagrams then. Now remember, Venn diagrams are just a way for us to visually kind of show, what's going on in the set. Now, sometimes you can list the numbers out, or sometimes we can kind of, write down what the set represents instead of having to list each element. So the Venn diagrams will definitely keep changing based on what example you have. So just to look at this example over here, they're talking about let J, and that's going to be the set J. Let J be the set of books Julio read this summer, and let R be the set of books Rose read this summer. So they're asking us to draw the Venn diagram for the set of books they read. If Julio read Game of Thrones, Animal Farm, and 1984, and Rose read The Hobbit, 1984, The Tipping Point, and Greek Love. So you can see between both of these readers, basically, the book that is common between both of them is going to be 1984, because both of them have read 1984, but none of the other books are common. So you can see, again, the rectangle represents your universal set, and the circle for Rose is showing she read The Hobbit, The Tipping Point, Greek Love, and 1984. For Julio, he read Game of Thrones, Animal Farm, and 1984. So since 1984 is common between both of them, remember this represents the intersection. So the intersection between Rose and Julio would be 1984 because that's common. So that would be the intersection between both of them, and that would be 1984. Now, if we were talking about a union between both of them, then that would list, The Hobbit, The Tipping Point, Greek Love, Game of Thrones, Animal Farm, and 1984. So you would list everything that Rose has read, everything that Julio has read, and then if they had anything in common, you go ahead and list that also. Even if there was nothing in common, with a union, you would still list all the items that Rose and Julio, or all the books that Rose and Julio have left. If you have something in common, that's fine. But if this was a blank space, union would still mean you combine everything from the 2 sets, 3 sets, whatever you have in there. So this is just, like I said, a visual representation of what your, sets look like, and just putting them in terms of a Venn diagram. And you can kind of read some of that description there if you wanted to. Now, this one, they're just kind of getting into a little discussion about inclusive and exclusive or, and of course, we talked about this when we were doing the logic section also. So basically, we're saying if you're talking about the exclusive or, then we're just talking about it means that your set would include just A or B, but it would not include both of them. With the inclusive or, which is kind of what we use for our discussion here, when you're talking about the inclusive or, you are talking about including what's in A, including what's in B, and including what's common. between both of them. And that's kind of how we work with our union of sets over here, because we are using the idea of the inclusive or in our discussion. So just, that differentiation between inclusive or exclusive. So very, very similar to what we had discussed in logic. And you can kind of see how those same concepts from logic are now getting into, set theory. So they kind of build up on each other. So if you can get a good understanding of one, you can get a good understanding of the other. So there's just a couple more examples over here where they're getting into, how you can use Venn diagrams to solve some of the problems over here. So let's actually pick an example from the end of the textbook so we can actually work on one ourselves and kind of break it down. Okay. Let's do number 8. Another thing I wanted to mention is we did include the odd numbered answers for your textbook in your D2L course shell. So if you were to go under your D2L, go under content, and then the textbook section. So if you go under the e-textbook, you will see that I included that PDF document for all the odd numbered answers. So, if you're looking at examples, working on your own, you can find those answers in here. So like I said, we'll work on number 8 over here. So we need to come up with our own Venn diagram for this. Okay, so let's see all the information we have. A survey asked buyers whether color, size, or brand influence their choice of cell phone. The results are here, and then they want to know how many people were influenced by just the brand instead of, color and size. So let's take a look at, first of all, how many circles do you think we need to create for this? Yeah, very nice.
3.
Wonderful. Very good. Yeah, and Michael, I saw your answer also. So let's go ahead and get our basic shape going over here. So we'll start with a rectangle. And then we'll need 3 circles. Okay. And we will definitely create them as overlapping circles, since, there might be some overlap happening between the color, the size, and the brand. So something like this. Okay, and then let's see, they're talking about 5 said only color, was the influence for them. 8 said only size. So remember, when you're talking about only color and only size, then we're basically saying there was, it wasn't color and size. It was just the color itself or the size itself. So the way you would place this, let me see if we can do it this way. So, this is, of course, going to be our universal set. This one can be for color. This can be for size. And then this one can be for the brand. And then let's say they are telling us 5 is only for color. So that number 5 will actually go in here because that's telling us it has no influence with the size or the brand of it. So same way when they tell you it's 8 is, 8 people were influenced only by size, that number 8 will go in here. So the keyword here is actually only when they're telling you it's only color or only size. Then in the next clue, I'm going to move this a little bit to the right. It's telling us 16 said only brand, 20 said only color and size. Okay, so 16 said only brand. So since it's only brand, that 16 will go in here. But then 20 said only color and size. So where do you think, when they're talking about only color and size, where do you think that 20 needs to go?
It would go in the little spot right in between the color and size circles, right above where all 3 of them connect.
Yeah, very nice. And then Amanda, I see your answer also, the top middle section. So that's actually going to be between color and size. So, of course, this is our color, this is our size. The overlap between them is going to be right over here. So that's where that 20 is going to go because they're specifically telling us that's only color and size. So again, the brand had no influence on those 20 people. Now, your next clue is saying 42 said only color and brand. So where is your color and brand going now? Color and brand. And that was
Only where color and brand intersect.
right. So that's going to be that little overlap between the C and the B, and that was 42 people. So that will be right over here. Okay, so our next clue is, and I'll move this again a little bit. It's telling us 53 is for size and brand. So 53, again, only size and brand. So obviously that guy will go in here. And then they're telling us, let's see, that was the third one. So the last one is 102 said all 3. So where are you putting all 3 at?
In the middle where all 3 of the circles intersect.
Very nice, perfect, because obviously that's where your color, size, and brand are all intersecting with each other. So that 102 is going in here. And then you also have a group of people, 20 of them who said none of these had any influence on them whatsoever. So 20 people said color, size, or brand didn't matter to them. So where do you think then that number should go?
Outside of all the circles, just in the
Very
rectangle.
nice. Yeah, Michael, good job. So in this case, because they're saying color, size, or brand had no effect on us, those 20 people, if they purchased a cell phone, probably had another criteria, maybe the price, or, something like that, or what was coming with their plan. I mean, many other reasons, but those 20 would go outside the 3 circles, but obviously you can see they're still going to be within the rectangle because that's our universal set over here. So that's what they're asking us to do. Is the first part is come up with our Venn diagram with all the values. Then you answer the question, and the question was, how many people were influenced by brand? So I'll give you guys a minute to think about it and then tell me what you think that answer should be. Okay, Terry, I see your answer. Now, again, the question is, how many people were influenced by brand? So how they're writing the question is very important here. And let me see if I can try and get both of them. on the same screen. Okay, so if you're sharing your answer, go ahead and send a direct message to me so I can see what numbers you guys are thinking about. How many people were influenced by brand? Okay, Terry, I see that you've changed your answer. Amanda, I see yours. Okay, Michael. Brooks, okay. Amanda. Sabrina, okay. Destiny. Okay, so when we're talking about how many people were influenced by brand, the one thing you have to kind of notice here is they are not saying only brand, right? They didn't say only. So it's definitely not going to be 16 because that's a number, they've already given us. So when they're saying brand, you are actually looking at all the values that fall under the circle, which is for the brand. So that is going to be, of course, the 16, but then the 42, the 102, and the 53, because all of them fall under this circle of the brand. So all four of those numbers have to be combined together because the 5 here is only for cell phones. The 20 is cell phone and size, and the 8 is only for size. And then, of course, the 20 on the outside didn't take any of those into consideration. So yeah, you have to take all four of these numbers and add them together to get your total. And some of you were like one off. I'm not sure what happened, if it was just a typo or what, but 213 should be the correct answer because Michael, you were one over. Amanda, you were one below. Brooks, you were about 2 below. Oh, mental math, okay. No worries. So yeah, that's what you are doing because they are just saying how many were influenced by brand. So that doesn't mean you cannot include people who also were looking at size and color. As long as brand was one of the things they were looking at, it becomes part of the answer. Everybody okay with that? Alrighty. So let's get back to our handout here. So you will see that's kind of what they are doing in this example here is, they're giving you all that information and then they're asking you how many people drink tea in the morning, how many drink neither tea nor coffee. So once you have the Venn diagram and you have all those numbers, placed where they should go, then it becomes very easy for you to see, which people fall under what category. And then based on that, you can answer the questions for that. So this one is talking about transportation, same kind of thing. They're giving you what category the people fall into, and then based on that, you come up with. So maybe, let's see if we can find something like that. Okay, let's look at number 10. That's kind of similar to what that example is. Okay, so this one is saying a survey asked people what alternative transportation modes they use. Use the data to complete a Venn diagram, then determine what percentage of people only ride the bus and how many people don't use any alternate transportation. So looking at what they have given us over here, how many circles again should we have in our Venn diagram? 3. Alrighty. You have, of course, talking about the bus, the bicycle, and walking. So as you can see, those would be our 3 categories over here. Yeah, Destiny, very nice. So let's go ahead and basically we'll be repeating our basic structure over here. Mm. Okay, I was kind of hoping it would let me do a copy paste, but it doesn't look like it will let me do that. Oh well. Okay, so we've got our universal set, and then we'll do our circles. Alrighty, so we will have our bicycle, of course, universal set on the outside. Then we had bicycle, bus, and then walking. Okay, so let's see. Okay, so they're telling us 40 use the bus, 25 ride a bicycle, 33 walk, 7 use the use the bus and ride a bicycle, 15 ride a bicycle and walk, 20 use the bus and walk, and 5 use all 3. So one thing you will notice is they didn't give us any information about only, right? Only ride a bus or only ride the bike or only walk. So this one is going to be a little bit more complex than number 8 because they gave us a straightforward only so many did the color, only size, only brand. You don't have that. So when they say 40 use the bus, where do you think that 40 goes?
Under bus.
But is it going to be just that section which is outside without the overlap or, in the overlap, like where?
I would say it'd be in no overlap, just under bus.
Just under bus? So specifically, guys, since they are not telling us that this is only bus, that actually means 40 is going to be the total of all. So not universal either, because 40 is going to be all of these areas together. So the total for your bus should actually be 40, and the same thing for 25 who ride a bicycle. So what you actually want to do is try and do the overlapping areas first. And even in that case, start with the one that says 5 are using all 3, because we know that's going to go right here in the center. 5 are using all 3, because if you can get those overlapping areas taken care of, then I will show you how you can do the only section of it. So in questions like these, where they don't give you the only bus or only bicycle, only walking, start with the intersections first. And in this case, since we have 3 circles, start with the all 3 first. Then you are going to do the intersections between walking and bicycle, walking and bus, bicycle and bus. So you're kind of working from the inside and making your way outside. So let's see what of those information do we have here? So this one is telling us 20 use the bus and walk. So bus and walk would be this section here. So that's where your 20 is going to go. Oh, actually, no. Sorry, my apologies. Because we already did the 5, because that 20 also has the 5 who use all 3. So we will actually be subtracting 5 from that. I didn't think about that. So 20 minus 5 is going to be the bus and walking. Riding a bicycle and walking, they told us 15. So same thing, since we know 5 do all 3. Again, we subtract 5 from this. So that means you are only looking at 10 people who are using the bike and walking. So bike and walk would be this guy here. Are they telling us anything between a bicycle and a bus? So what number do you think we will put in here between bicycle and bus?
2.
I'm sorry, would you say that again?
2.
Yeah, same thing, because you have to subtract the 5 again in this case. So you can see over here, they're telling us 7 people are using the bus and the bicycle. So same thing, subtract 5 from that for the all 3 category, and that leaves you with the 2. Okay, so now that we have all the overlapping areas taken care of, I want you to think about what the only number for bicycle, bus, and walking is going to be. And you will have to take into consideration, all the overlapping regions and subtract that from the numbers given to you to come up with these only bus, only bicycle, only walking. And again, guys, if you are sharing your answer with me, please make sure you're doing it as a direct message. Okay, Destiny, for which category was that number? For the bus, okay. Michael, I see your answer. Okay. Michael, it looks like you've left something out because your numbers are coming out to be incorrect. I would say check one more time. All right, let me see. So, Destiny, your number looked good for the bus that you sent me. Terry. Terry, check your numbers again. And then let's see, Amanda, you have. Amanda, that looks wonderful. Very good. Brooks, that looks good. Very nice. Sabrina, your bike is looking good, but I would check the walking and the bus. Destiny, those numbers are too high. Check your math again. And then Michael, I see your updated answer. So let's see. That looks good, Michael. Yeah, very nice. Okay, Sabrina, let me see. Yeah. So the 33 is for walking. So you're doing walking. Yeah, that looks good for walking. So walking, what did your number come out to be? Okay, Destiny, I see that. Yeah, Sabrina, very good. Yeah, so 40 total use the bus, and then you have to think about all the overlapping numbers that you have in there, Sarah, and then you would have to, remove those. So basically, every circle, has those three overlapping sections, basically, as you can see. So, like when you're looking at the walking circle, you have to think about the 10, 5, and the 15, which are in the overlapping section. So, they're telling us that 33 are walking. So when you're looking at the Venn diagram for the walking, then, you would have to do 33 minus the 10 minus the 5, minus the 15, which basically, the 10, 5, and 15 comes up to be 30. So you're subtracting 30 from 33. So that would, then end up giving you 3. That number looks good, Sarah. Yeah, for the bike. Very nice. Very nice, Destiny. Yeah. So now we've done the walking. Let's do the bicycle, people. So they're telling us, let's see, 25, ride the bicycle. So bicycle would be then 25 minus the 2 minus the 5 minus the 10, which basically comes out to be 17. So 17 taken away from 25 leaves you with what, 8? So you should have 8 left behind for the bicycle people. And the last one was the bus. All right, Sarah, very nice. The bus would be 40. So they're telling that, 40 are using the bus. Minus basically the same number of, let's see, 2, 5, and 15. So that is going to be what, 22. So 22 will leave us with 18, as you guys had. Alrighty, did they tell us anything about who is not using this transportation at all? Did we have anything about how many people were surveyed or anything? So we had 5 who use all 3. 15 who use bike and walk, 20 who do the bus and walk, 7 who did the bike and the bus, 33 walk, 40 use the bus, 25 ride a bike. I'm not seeing any mention of total number of people either. Something doesn't seem right here because we should have a number for the outside. Okay, so Sarah, you're saying there are 98 people total. I actually want to see if there is a error message because this is not looking right to me. No, there's nothing from 1.2 in here. Because they're specifically asking us how many people don't use any alternate transportation, but they're not giving us that information. And all of this information given to us only helped us create the inside of the circle. So we don't really have a number out here. Because, you know, the idea is if you look at 40 who use the bus and 25 who ride the bicycle and 33 walk, we cannot just add those three numbers together because we know a lot of those have overlaps in them, right? So you cannot just add what they're talking about, how many people walk or bike or take the bus. So there should have been some other information in here. Terry, go ahead.
Would we be basing it off of 100%?
That's the only other option I can think of, because as far as just using the numbers go, but then, you know, again, let's see, I'll have to kind of work the math out to see if that works out, because right now, what's your total number coming out when you do only the people inside the three circles?
$98.
That's not what I came up with. Okay, let me check my math one more time. Yeah, I'm not getting that. Michael, you said 98. Sarah, you said 32. Okay, tell me then, why am I getting a different number here? Okay, Destiny, you're close to what I came up with. I got 61. Okay, let's see if I can bring my calculator out forward. Okay, so you can see we have, okay, Destiny, yeah, that's what I had. Okay, let's take a look at this here, guys. Yeah, I will, Sabrina, that's a good idea. I will definitely try and see if I can send something out to the authors of the book. So if we try and put this together, let's start with the bicycle circle. So you've got number 8 over here. So that's going to be 8 people for only bicycle. Then we have 2, 5, and 10. So then we're adding 2, 5, and 10. So that's the bicycle people. And you can see that does add up to 25, which is what they told us in the problem. Then moving on to the bus circle, you've already taken care of the 2 and the 5. So that would be the 18 and the 15. So then we're adding 18 and 15 to our total, which then brings us down to the walking circle. And we've already got the 3 overlapping areas taken care of. So that just leaves us with the 3. And that's how I came up with the 61. So that's the total that we are getting from the circle. And then Terry, as you were suggesting, which is kind of what I was thinking, which again, this can be such a vague thing to say, because when you are saying what percentage of people, that percentage is calculated from what your total is. There's nowhere that they're telling us we have a total of 100 people that were surveyed. So I don't know if this is adding up to 61, and when you subtract 61 from 100, you get 39. So does that mean you have 39 people who did not do any alternative transportation at all? Because again, we're making that assumption that there's a total of 100 people. They are not there. So based on that, if we were to calculate the percentage, and this one is what percentage of people only ride the bus, then only ride the bus would be 18 over here. So now are we taking 18 out of the 61 total that we have? Because that percentage is going to come out to be different, because in that case, when you're talking about 18 out of 61, that is approximately 29.5%. But then if you're thinking about 18 out of 100, well, obviously that's 18%. And then same thing, how many people don't use alternate transportation? This was part A. So part B could be 0 out of 61, since they didn't tell us anything about people. Or are you doing 39 out of 100, which then of course comes out to be 39%. So this one I will definitely make a note about sending something out to the publishers, because I don't like that ambiguity of the problem. Because what if they had surveyed 200 people? Then that would be 139 who were not using transportation, right? There's no information telling us anything about total people who were surveyed, or anything about people not using any of that transportation. So I think this might be just an overlook that happened, but you still kind of get to see how the Venn diagram was designed, how we had to start from the inside where all three were overlapping and kind of work our way outward. So there is definitely a good distinction between what you saw in example 8 and what you're seeing here in example 10. So at least you get that sense. But like I said, not knowing a little bit more information is definitely kind of giving you, a little bit of a different answer. So your textbook solution is definitely assuming that you have a total of 100 people. So this is the answer that they are giving us for parts A and B, but I am not convinced that should be the answer, since we don't have enough information. But that's kind of what they're doing. So if you guys run into anything similar with homework, let me know. Even though I did look at all the homework problems, but it's very easy if I overlooked anything. So if something like this comes up, don't hesitate, reach out and let me, so I can at least make a note of it, or email the author about it. Okay, so other than that part, any other kind of questions coming up to you guys? Yes, you can practice with the odd questions. And like I said, you do have that answer key that I posted in D2L. So again, folks, you will see they're giving you a lot of different examples, just showing you how you can work with different Venn diagrams, just giving you something with 2 circles in there or 3 circles, depending on how many sets they had. So of course, here with the tea and coffee example, you had 2 sets, then we kind of got into the 3 set example. So you can definitely use these guys as your resources. Now, the last part that I wanted to talk about was what we mean by qualified propositions, and then just, kind of looking at these overlapping and disjoint sets. So when we're talking about qualified proposition, we're basically talking about where you are kind of using these, what we call as qualifiers. So the words like some or no or none and all, when we put those, when we're talking about what kind of relationship you have between two sets. So in this case, you can talk about some elements which would be shared between two sets, none. So that means no elements would be shared between the two sets, or all, which of course then implies that we're saying all elements of one set are contained, excuse me, in the other set. So you will be seeing examples on these qualifiers. Think about when we're talking about overlapping sets, that's basically where we are talking about the sum. So we're basically saying some elements are common between both of them. So, kind of think of that as being intersection. So in this case, they're talking about people who live in Southeastern Portland and students who are taking the Math 105 class. So that's, at Portland Community College, that's their Math for Liberal Arts class. So basically you have students who live in Southeastern Portland, students who are taking the Math 105 class. And then, of course, there would be students who are both living in that area and also taking that class. So that would be your sum. Students live in Southeastern Portland, take Math 105. So, again, that intersection that I was talking about. When we're talking about disjoint sets, we're talking about the none, right? So that means no elements are common between the two sets. So in this case, we're talking about you have a set of cats and you have a set of dogs. And, of course, they are two different species of animals. So obviously there would be no overlap or nothing in common between the two sets. So in this case, you can see how your Venn diagram looks different from the one above that. Is because this is disjoint, there's nothing in common. So they wouldn't even be touching each other, forget about being overlaps. So that's what a disjoint set would seem like. And then when we were talking about the all elements from one set are contained in the other set, you're basically talking about a subset over here. So if you have a set of maple trees, and then you just have a set of all types of trees, well, obviously maple, is a type of tree. So that would be a subset for the bigger set, which would be the types of trees. And maybe the universal set could be, all kinds of fauna, so plants, trees, shrubs, grass, maybe that could be the universal set. So you have maples being the subset of the tree set, and you can see your qualified proposition could be something like all maples are trees. So that's kind of how these qualifier statements work. And you can see how each one of them, depending on which, word is basically being used. Are you using some, none, or all? Based on that, you would then have different types of Venn diagrams. Oh, why is this not letting me move now? So I know we're kind of out of time almost here, but we can see if we can find an example for that and maybe work on it next time. So we'll pick one of these examples and work on that, but that's the last part we need to do in this section for 1.2, and then we'll move on to section 1.3 on Friday. So you guys should hopefully be able to get through most of the homework for section 1.1 and 1.2. And then, like I said, we'll wrap up this last part with the qualifying statements, and then we'll get into section 1.3. Yeah, Destiny, we're done for today. So again, guys, let me know if you have any questions. Sabrina, I know you were going to stay and ask me a question, so that's fine. If anybody else has a question, please stay back and I'll be glad to answer. And if not, I will see you on Friday. So have a wonderful afternoon, guys. Take care. Be careful, and I'll see you on Friday. Bye, everyone. Take care. Thank you.